welcome to my YouTube channel. Today I'm doing the vertical projectile of motion, and it's September 2024 in the Western Cape province. I've done the other questions, but I'm gonna do bit by bit. Now let's look at this one. It says learners in grade 12 launch a model rocket from rest. Very important information from rest. Now it says vertically upwards from the ground, right? It says assume the rocket experiences a constant acceleration for 1.8 seconds. Very important, right? And then to reach the maximum height, to reach the maximum velocity of what? 29.7 meters per second, at which point it runs out of fuel. It says ignore the effect of air resistance, right? Now it says here the sketch below is not drawn to scale, represents the position of the rocket relative to the ground from the moment it's launched until it crashes back to the ground. Upward direction taken as positive. So they already chose the direction for us, up as positive, right? Now, what are they saying? This is the rocket. We'll say this is point A. It starts from point A at rest, which is the initial velocity at A, and then it is launched. And while it's launched here, it has a fuel and it has a constant acceleration. And then when it gets there at point B, it runs out of fuel. And for how many minutes? It says assume that it experiences a constant acceleration here. It has a constant acceleration here, right? For how many seconds? For 1.8 seconds. And then when it gets there at point B, it runs out of fuel. That means from point A to point B, it has a what? Constant acceleration, right? And from point A to point B, it travels for 1.8 seconds. From point A to point B, the initial velocity is 0 and the final velocity is the velocity, it says here, to reach the maximum velocity of 29.7. So at point B, the final velocity is 29.7 meter per second, right? And at point A to B, it was not in a free fall, because it was not only gravitational force that was there was a force of fuel because it was moving, used by the fuel from point A to B. There it ran out of fuel, right? So then from point B to the maximum height, which is, we're going to say it's point C, right? So from B to C, it had ran out of fuel, and there was a speed decrease there. From B to C, there was a speed or a velocity decrease, right? Decrease there. Okay, let's add another point. From B to C, there was an increase in velocity. Increase in velocity there, or speed, right? And then from point B to C, it was on a free fall. So it was only gravitational force that was acting on it. And then the initial velocity at point B to C, it was this velocity at B, which is the 29.7 meters per second. And the final velocity, when it reaches that maximum point, as I mentioned, that the velocity decreases. It decreases up until it's what? It's 0. So the final velocity there is what? Is 0. So the final velocity there is 0. And the velocity here is 29.7. Right? And then the fuel, it crashes back to the ground in the negative direction. This was a positive direction, and this is the negative direction, right? So the height or the distance it traveled the same distance from A to C is the same distance from C to the ground. So let's say the ground is what? It's D. Okay, let's answer the questions now. I hope that makes sense, that explanation there. It says during 3.1, during which intervals was the rocket on a free fall, as I've mentioned? It was on a free fall where from this time to this time, which is from B to C, but we cannot say B to C because we are not given B to C here. We're going to use the time interval from what? From 1.8 seconds to what? To T1. No, not to T1. The whole journey from here to here, it was on a free fall. It was only gravitational force. Even here, it was on a free fall, only gravitational force that I was acting on that. So it's from 1.8 seconds to T2 up until it reaches the ground. Now, at 3.2, it says calculate the constant acceleration the rocket experiences between 0 and 1.8. So what is needed in 3.2 is this acceleration. So we're going to use the acceleration here. It travel with the constant acceleration. So we're going to use the segment A to B. So I'm going to say 3.2 and state that we're using the segment A to B. So we're using that segment A to B. What do we have in A to B? In A to B, we're looking for acceleration, which is it's not 9.8, guys. And then what else do we have? Do we have time? It's 1.8. And what else? We have initial velocity at A. And then we have a final velocity at B, which is it's 29.7 meters per second, and they both positive because it's going up. So which formula are we going to use there? Which formula are we going to use there? We're going to use the formula that says V final minus V initial plus AT, right? The V final is 29.7, the V initial is 0, and plus the acceleration is the one that we want, and change in T there, right? I hope I do make sense by that. So what are we going to do? Okay, what I didn't substitute is the time. Let's substitute the time. It's 1.8, right? It's 1.8, and then we have 1.8 there. So we're going to have 1.8a is equal to 29.7, and we divide by 1.8. We divide by 1.8 there. So the acceleration there, it's going to be 16.5 meter per second square, right? And the acceleration direction, it's accelerating this upwards, right? Okay, now in a 3.3, it says calculate the maximum height H2 above the ground, which is the H2 above the ground is that. So it's that. So what are we going to do? We are going to calculate two ways: the displacement from A to B and then B to C. So it's 3.3. I'm going to use A to B. And what do we have to A to B is the same things that we have. So the formula that we're going to use is VF squared, V initial squared, plus 2A, change in Y. The V final there, from A to B, it's still 29.7 square, and the initial is still 0, and the acceleration is the one we just got. It's 16.5. Let me punch in the calculator and say there's something that I just want to double check. 29.7 divided by 1.8 divided by 1.8. Yeah, it's 16.5. Okay, the acceleration, it's 2 times 16.5 dy, and then we're going to have 2 times 16.5 change in y equal to 29.7 square, and then we divide by 2 times 16.5 both sides, 2 times 16.5, and then we're going to have the change in y. This change in y, it's a to b, very important, it's a to b, so it's going to be 26,73 meters. So that means the displacement or the height is from there to there, or from, this is h1, right? This is h1 from there to there. It's what? It's that. So now let's do for b to c. B to C. So this is H1, guys. And then let's do for B to C, which is the H2. Right? So what are we going to do? We're going to use, remember, this is a free fall now from, it's a free fall now. This one is not free fall, the one we just calculated. What am I doing? No free fall. So what are we going to do? We use the same formula. And then what is our V final there? What is our V final is 0. And then the V initial is going to be 29.7. The V final is 0. And then the V initial is 29.7 square plus 2 times the acceleration is what? Is negative 9.8. Remember, it's in a free fall, it's negative 9.8, and up was chosen as positive. So when you do the math here, we're going to have 29.7 square, and then it's going to be negative 19. This is going to be negative 19.6 change in y, and then your dy, which is your b to c, it's going to be when you punch that in the calculator, it's going to be 45 meters. And then I'll say the height h is h what? It's h2. The h2, which is the maximum height, which is, it's going to be, you added the 2, it's going to be 26.73 plus 45, it's going to be 71.73 meters, right? I hope I make sense by that one. Let's go to 3.4. 3.4, it says calculate how long the rocket was in a free fall, and hence the value T2. How long was in a free fall? When it was in a free fall, it was in a free fall from here to here. When it lost the fuel, when it ran out the fuel, and then to the maximum height and crashes back to the ground. So very important there. So we have to calculate the times there. We have to calculate the times. So calculating times there, we're going to calculate the time of what? Of B to C, right? We're going to calculate the time of B to C, which is we have initial velocity and the final velocity. And that is a free fall. It's 3.4. 3.4. So we're going to use B to C. We already have time for A to C. So we're going to use the formula that says V initial plus AT. And then the V final is 0, which is the maximum. And then initial, it's when it ran out of fuel, it's 29.7 plus. The acceleration is negative 9.8, change in T. Right, it's going to be 29.7 equal to negative 9.8 change in T, and then we divide by negative 9.8, negative 9.8, and then your delta T, it's going to be, when you punch that in the calculator, 29, 29 29.7 divided by 9.8. It's going to be 3.03 seconds. Right, let's go to calculating the time now from C to D. Calculating the time from C to D. What are we going to use calculating the time from C to D? We have the velocity, which is the initial. We have the displacement, because the displacement from here to here, it was this 70 something, 71,3. So we have the initial velocity, and we have the initial velocity and the displacement. So the formula that I think is suitable for that is going to be this: dy v initial change in t plus half a t square. All right. So the dy, the displacement, since it's going down, it's going to be negative 71,73 equal to the v initial is what? Is 0, because it's the v initial, it's at the top. The top is 0, and then the time is going to be 0 there. So plus the acceleration, it's 9.8, and change in t, that's the time we want. So this is going to be negative 4,9, change in t squared, 71,73. We divide by negative 4,9. We divide by negative 4,9. So we're going to say, and then we put the square root, the answer. So it's going to be square root 71,73 divided by 4,9. So the answer is 3,82. Okay, let's say 3,83 seconds. So the total time, it's going to be the 1,8, which is from here to here. It's 1,8, and then we calculated this one, and we calculated that one. So the time here, it's 1,8 plus 3,03 plus 3,83. So plus 1,8 plus 3,03. The time here is what? 8,6. Let's say 66 seconds. 3.5. It says sketch velocity time graph on your answer book for the motion of the rocket from the moment it's fired until it hits the ground. Clearly indicate the following on your graph. These are very important bulletins, guys. You need to make sure that you mention these. So the velocity, okay, let's do this. Let me draw it here. It's going to be something like that. It's velocity meter per second. And then it says the velocity of the rocket when the fuel runs out. The fuel runs out here, which the velocity is 29.7. So the rocket, guys, it started from rest, and then it moved up, right? It moved up, right? And then what happened? So it started from rest, and then it moved up, and then once it moved up there, so that velocity is 29.7. And then what happened here? From here to here, the velocity decreased, right? The velocity decreased, and then now the difference between these two times, here the velocity it decreased to 0, but it was on a free fall, right? So it was decreasing. Okay, what is important, guys, here, what I can tell you that is simple, from A to B, the velocity was increasing and the velocity here was decreasing to 0. So the decrease in velocity, how do you show it? You're gonna show it that way. It was decreasing to the maximum height, right? To the maximum height, which is to C, from C. So let me label maybe in the graph. This is A, and this is B, and this is C. Okay, let me write C aside, C. And then what happened? What happened? It continued further down in the negative direction, which is the velocity was increasing, but where? In the negative direction. So this velocity, guys, don't be shocked when it's going down. The velocity, it's not going down in the negative direction as it going down here. So when the velocity decreases here, it decreases still in the positive direction. Look at the graph, it's above the x-axis. That means it's still decreasing in the positive direction. So here it's C, which is at the maximum height there. It increased now in the negative direction. So this one is a positive direction and this one is a negative direction, right? And then let's show the time. So this here, this is when it stopped. No, not it stopped. The fuel stopped, which is the time. It was what? 1.8. Okay, it says the velocity which the rocket was, which is we're shown that, and then the value of T2 when the rocket crashes on the ground. So we showed the 1.2 and the T2. We need to show the T2 when it crashes on the ground. It crashes on the ground at what? At point D. That's point D, right? That's point D. What was the time at point D when it reached the ground? It's 8.66. So the time here, it's 8.66, right? And the time is what? Is seconds there. So I think, and this is going to be at C, and with C, it's the maximum. It's what? It's T1, right? And I think that's it about this question. I hope you understand, guys. Cheers. Bye.